So, yes, let's go ahead, Jack.
So, hi, I'm Jack, and I'm in the 8th grade. And today, or this week, I made a security system with Arduino, which is this, and I'll tell you more about it later. And if you don't know what a security system is, it's one of those devices that sets off an alarm when someone gets close. And it sets off a really annoying noise. And this is my not as well produced $50 one. So yeah. So the goal for me was to create a security system using Arduino. Yeah. So the design, and I used it's the software called Fritzing, which allows you to make diagrams of design. So what it does is it senses something with this ultrasonic sensor, and then it lights up these LEDs right here and plays a sound accordingly. And then if you get too close, it'll start beeping and stuff, and it'll have you put in a password with these buttons here, and then it writes statements accordingly on this LCD screen, which stands for Liquid Crystal Display, and prints out words. So yeah. So building the components, there's the Arduino, and not everything that I use is represented up here. But so the Arduino, which is the board, it's used for making circuits, and it's the main processor. It's what you upload the programming to, and it's the center, and it has these digital pins and analog pins, which allows you to control it from a computer and program it and stuff. And then these are breadboards, these long boards with columns and rows for wiring. And then if you're making circuits, wires, they carry currents, they're metal and electricity, woo. Resistors, they limit voltage and the current. The potentiometer, it's like a resistor, but you can control it with the knob. LED lights, yeah. So the buzzer, it plays this. High-pitched frequency sound, gets on people's nerves. All the people in Codologie can attest to that. I have to test a lot, okay? So the ultrasonic sensor, it detects something, like I said earlier, different distances. Push button, it's a button, enough said, y'all. The liquid crystal display, it displays text. And then tape, it's sticky, wow, because when you use 50 wires, you kind of run out of one type. So, I don't even know how many are in here, and I kind of ran out. So, and also a lot of them are short, and it's hard to go from here to here. So, components. So, the code, and I'll show you guys this later, or after this slide. So, a few helpful functions I used. Pin mode, it's what sets up the pin. And again, the pins are these little holes, these digital and analog pins, and it's how I control stuff from my computer. Digital write and read, it turns the pins on and off, and then that's write, and then read, it reads the state of the pin. Pulse in, it's essentially sort of a stopwatch, reading time between the high and the low of the pin, and that helps me with something that I'll tell you later. Serial prints out stuff, and it helps me check what's working. And then delay, it stops the code for a specific time. This was probably the most annoying part of it. It's the distance formula I had to use to figure out the distance from the ultrasonic sensor to the object. But that's my screensaver. It's Battle of Hoth. I'm a nerd, so yeah. So it helps me figure out the distance from this ultrasonic sensor to the object. And so the distance, it only comes in time, microseconds, which is 1/1,000,000th of a second. So this distance formula calculates the distance in centimeters for me. So it's distance times the speed of sound, which is 340.29 meters per second, times 10 to the negative 6, so that way it gets reduced down to microseconds, times the duration of the trigger and echo function, which is also something I'll show. because there are different like things, there are different kinds of, there's like a specific name for these. The trigger sends out the signal and then the echo receives it and like reads it. So time divided by 2, which because it goes this way and back and it'd be double what the distance actually is, so you have to divide it by 2. And then times 100 because this is in meters and times 100 puts it into centimeters, because otherwise it's like 0.17 blah. Tiny. Oh wait, no. So here is the code that I have. Let me go to the top. So first, hashtag include liquidcrystal.h is a library that imports all these LCD display functions that I need for stuff. These are a bunch of variables that I used in order to do stuff. So this sets up the LCD display. So void setup, it's the stuff that runs once, like this little helpful comment here that says, put your setup code here to run once, and it's really good for stuff. And this is where I set up all the pins. So I have to set them up so that they say input or output, because otherwise like they won't work if I don't set them up, such as a computer. And then here's the loop that runs like over and over again. So first, what it does is it sends out the ultrasonic signal, and that's on pin 19 and pin 6. The 19 is the trigger, and then 6 is the echo. So pulse in is that function, that stopwatch thing. It's how to calculate time. So here is the distance, and this is just a simplified version to make it run quicker. And then it prints like some stuff that you can't see, but there's other stuff you can't see. Here's all the if statements that calculate the distance, and it'll be more apparent what those are for when I run this. So it does different little light effects depending on the distance it is away. Okay. So down here, what this is the function, or not function, the loop that runs the button passcode logic, and there are different variables for reading all that. And pretty much this says if there's this variable I created that just keeps track of what step you're at. So if you're at the first step and the first button in the combination is high, which is on, then it beeps and moves on to the next. And that's the same for all this down here. And then down here is for if you fail the combination, then it writes fail on the LCD screen. So disheartening. And then it beeps to let you know you failed. And then, so here's a variable I created called wrongness. Yeah. So if you get it wrong, it takes the variable wrongness and adds 1. So if you get it wrong 3 times, then the alarm is equal to true, and then it beeps forever until I reset it. And maybe I'll torture some of them just because I want to, because I'm evil. So I will run this now.
Give me the alarm.
Uploading. Okay. Oh wait, hold on. Let me go.
Can you press reset?
Yeah. I just move this up. So here are the LEDs, and if I get, so there's the passcode, and I input it 1, 2, 3, 4, 5, and then it does a little loading thing with these LEDs, and it beeps twice, and it says disarmed on this LCD if you want to come closer and look at that.
Nice.
And yeah, disarmed. And if I reset it, so sometimes the distance is a bit finicky just because the ultrasonic sensors don't work that well. But so if I'm a certain distance away, it does 2, and it does 1 if I get far away. There it goes. and then 2, 3, and then here it starts beeping because something triggered it, and it says something's here. Enter passcode, and I'm gonna get it wrong this time. So it says fail. Oh god. Fail. Oh no, something's here, and they're trying to break into my house.
And they don't have the right passcode.
So that's essentially what it does. So testing, there are a lot of problems. That was like my face for half this entire project. So most things didn't work because of wrong wiring and code errors and wrong pins for stuff and other just dumb stuff because I don't know everything. So sad. And then rethinking happened. And I fixed all these aforementioned errors, and I added more stuff as time went on. Because first it started out as just some flashing LED lights, and then I added a buzzer to make noise, and then I made it button controlled. Then I added this ultrasonic, and then I put in the passcode, and I put in this LCD in that order as illustrated by this lovely chart here. And the errors went away, and so did that face. And the result's this awesome. Thank you. Any questions?
How much wires did you?
I will not answer that, but what I can do is play that buzzer again. No. Anything else?
I did that.
What kind of, what did you notice about like your work ethic? I mean, because this obviously required like a lot of concentration. Would you work in like kind of small chunks in time, or did you notice you were just like working hours on end?
I noticed, I think I was fairly focused for the entire time, but because I don't get to do hardware and circuitry that much, I do mostly just code, because I take classes here and it's just mostly code for me. But I thought actually the circuitry was actually pretty fun and it was nice to do for a change. And I think I worked pretty hard on it and pretty consistently, except for the times I was multitasking and playing Pokemon Go at the same time.
I heard about that.
So, yeah. Anything else?
I was going to say, both of you guys did a great job presenting with all these rugrats making all this noise. So thumbs up.
Excellent focus.
Thumbs up, guys.
Thank you.
Thank you.